Hello students. So let's continue with the problems based on trigonometric identities. So as you know, the rules we have discussed in the previous video and the previous video before that also. So let's solve this problem. 1 plus secant a by secant a is equal to sine square a by 1 minus cos a, and they've given us the hint also. Simplify our LHS and RHS separately. So let's understand why we have to simplify LHS and RHS separately. First, let's follow the rules which we have learned. Okay. So let's take the LHS first. What is the LHS here? It is 1 plus secant A by secant A. Okay. 1 plus secant A by secant A is the LHS. Now, is there any identity? We don't have any identity as 1 plus secant A. Therefore, we have to convert everything into sine and cos. So 1 plus secant A can be written as 1 by cos A divided by the other secant A. Divided by secant A can be written as 1 by cos A. In the numerator, as you can see, we have to take LCM. So let's do that. So multiply the denominator. 1 into cos A is cos A. Then crisscross. 1 into cos A is cos A. 1 into 1 is 1. Divided by 1 by cos A. Now here, as you know, it is in the form of A by B divided C by D. So what do? We keep the numerator, that is A by B as it is, cos A plus 1 divided by cos A as it is, into the reciprocal. 1 by cos A will become cos A by 1. If you observe cos A gets cancelled. Therefore, in the denominator we have got 1, we can exclude it, no issues. So it will become cos A plus 1 divided by 1. So anything divided by 1 is the same thing, isn't it? So what we have got is cos A plus 1. Now can we further proceed? Is there anything that we can do? No, isn't it? Because there is no algebraic identity, there is no trigonometric identity, there is nothing that we can do. But still we have not got our answer, isn't it? What was the RHS that we have to get? Sine square A by 1 minus cos square A. But we have not got it. So what we are going to do is, in such cases where you are not able to proceed further, okay, in such cases we have to solve the LHS and RHS both. Okay. Now let's take our RHS and solve it. Okay. So what is our RHS? Okay, our RHS is sine square A by 1 minus cos A. Same procedure. Is there any identity? Yes, there is an identity. That is, sine square A can be written as 1 minus cos square A. We know this identity. So let's use it. Sine square A can be written as 1 minus cos square A divided by 1 minus cos A. Now, as you know, this 1 can be written as 1 square, isn't it? So the numerator is in the form of a square minus b square. Therefore, we can write it as a plus b into a minus b. Here our a is 1 and b is cos. So a square minus b square, a minus b, that is 1 minus cos a into 1 plus cos a by the denominator as it is 1 minus cos a. So 1 minus cos a, 1 minus cos a gets cancelled. So we are left with 1 plus cos a, which can also be written as what? Cos a plus 1. Now, if you observe after simplification, in the LHS, what is the answer that we got? Cos a plus 1. After simplification, what is the answer that we got in the RHS? Cos a plus 1. So let's take this as 1. Let's take this as 2. From 1 and 2, LHS is equal to RHS. That is, we have proved the identity. LHS is equal to RHS. So in this question, there are certain types of questions where you'll be solving, but you are not able to end up at RHS. So in that case, you will solve the LHS, you will get an answer. Solve the RHS, you will get an answer. Both the answers will be same. Therefore, you can tell LHS is equal to RHS as we have done here. Okay. After solving LHS, what is the answer that we got? Cos A plus 1. After solving the RHS, what is the answer that we got? Cos A plus 1. Okay. Therefore, from 1 and 2, LHS is equal to RHS. Okay. Let's get into the next question. Okay. Now, what we'll do is we'll solve this question a bit later. Okay. Let's solve this bit later. Let's solve this question. Okay. Sixth one. Now, let's take the LHS. what is the LHS that we have got? Root of 1 minus sine A divided by 1 plus sine A. Now remember, whenever your numerator and denominator are in this form, A plus B and A minus B. Okay, you got same things, but with different sign, plus and minus. If that is the case, remember we have to use rationalization. Okay, that's what we are going to use. Okay, anything, if it is like A plus B by A minus B or A minus B by A plus B, you got same terms, but only thing is in numerator it is minus and the denominator it is plus, or the other way, plus and minus. If that is the case, then we are going to use rationalization. If you observe here in the numerator, you got 1 and sine A, denominator also you got 1 and sine A. Numerator it is 1 minus sine A, denominator it is 1 plus sine A. So if that is the case, what we are going to do is we're going to make use of rationalization. Okay, so how do we rationalize? Keep the root as it is, 1 minus sine A by 1 plus sine A. I hope you guys remember the procedure for rationalization. What you guys going to do is just change this plus, isn't it? We're going to rationalize the denominator. So 1 plus sine A, it will become 1 minus sine A by 1 plus sine A. Whatever you got in the denominator, the same thing with the symbol change. Here it is 1 plus sine A. So you're going to change the sign, plus as minus. So you're going to multiply and divide 1 minus sine A by 1 minus sine A. Now observe the numerator, 1 minus sine A into 1 minus sine A. It will become what? 1 minus sine A the whole square, isn't it? A minus B into A minus B is A minus B whole square. The denominator is like A plus B, 1 plus sine A into 1 minus sine A. It's like A plus B into A minus B. What is A plus B into A minus B? A plus B into A minus B is A squared minus B squared. Okay. Now, the next step, what we can do is root of 1 minus sine A the whole square as it is. 1 square can be written as 1, isn't it? And this 1 square can be written as 1. 1 minus sine square A, isn't it? In the next step, we'll use the identity. Okay. So root of 1 minus sine A the whole square, the numerator as it is. Denominator 1 minus sine square A can be written as what? Cos square A. Identity 1 minus sine square A can be written as cos square A. Now let's split the root for numerator and denominator. So it will become 1 minus sine A the whole square divided by root of cos square A. So if you observe, square and root gets cancelled. Even here square and root gets cancelled. So we are left with 1 minus sine A by cos A. Now here, if you observe, okay, I made a small mistake in the question. Okay, the question was root of 1 plus sine A by root of 1 minus sine A, but we have taken the reverse, isn't it? I'm sorry about that. No issues. You can just change this question as secant A minus tan A. Okay. So if you split the denominator, 1 by cos A minus sine A by cos A. What is 1 by cos A? It will become secant A minus sine A by cos A is tan A. Okay. So that's the answer. Now with the question, according to the given question, it was root of 1 plus sine A by root of 1 minus sine A, but I've just reversed it. I'm sorry about that, but the procedure is same. The task is, the method is same. Whenever you got A plus B and A minus B, the same thing in the numerator and denominator with symbol change. You're going to go with rationalization. If you rationalize it, you will easily get the answer. Okay. Let me, for your sake, let me do that and show you how to do this. Let me do this again. Okay. Anyhow, I've made the question wrong. I took the question wrong. Let me take the LHS properly now. What was the LHS? The LHS was root of 1 plus sine A by 1 minus sine A. Okay. Now let me erase this also. Yeah. So as I told you, we must go with rationalization. So how do we rationalize? 1 plus sin A by 1 minus sin A into, we have to rationalize the denominator. The denominator is 1 minus sin A. So you have to take it as 1 plus sin A by 1 plus sin A. So the numerator is like 1 plus sin A into 1 plus sin A. It's like A plus B into A plus B. So it becomes A plus B the whole square. That is 1 plus sin A the whole square. The denominator is A minus B into A plus B. So it becomes A squared minus B squared. So therefore, the next step, let me do it here itself. Okay. So it becomes root of 1 plus sin A the whole square. 1 square can be written as 1 itself minus sin square A. And the next step, we'll use the identity. Okay. 1 plus sin A the whole square as it is. Okay. 1 minus sin square A is cos square A. Okay. So here we can split the root. It will become root of 1 plus sin A the whole square divided by root of cos square A. The square and root gets cancelled. Square and root gets cancelled. So what we are left is 1 plus sin A in the numerator and divided by cos A in the denominator. We'll split cos A to both the terms in the numerator. So it will become 1 by cos A plus sin A by cos A. So what is 1 by cos A? It is secant A. Sin A by cos A is tan A. We have got our RHS, isn't it? So the same procedure that we have applied. Okay, let's get into the next question. Same procedure. We'll take our LHS. I mean, we are going to use the same rule. That's what I meant. Not rationalization. Sin theta minus 2 sin cube theta divided by 2 cos cube theta minus cos theta. As you can see, there is no identities involved, but you can observe that in both numerator and denominator you can take common. That is, in numerator you can take sin theta as common, isn't it? Remember, you should always take the least power as common. So here sin theta power is 1, here it is sin cube theta, the least power is 1. So if you take sin theta as common, you'll be left with 1 minus 2 sin square theta. So in the denominator, if you take cos theta as common, you will be left with 2 cos square theta minus 1, isn't it? Now, if you observe carefully, what we need, the answer is tan theta. If you observe here, we have already got it. Sin theta by cos theta is what? Tan theta, which means we don't need these things. If you somehow cancel these two things, we will get our answer. How to do that? You have to make both the numerators same. How do we make same? See, in the numerator is in terms of sin theta, but denominator is in terms of cos theta. But we'll convert it, okay, using the formula. Cos square theta can be written as what? 1 minus sin square theta, isn't it? Minus 1. We are just using the identity, okay? So therefore, in the next step, sin theta as it is, 1 minus 2 sin square theta as it is. Now let's multiply it. Cos theta as it is. 2 into 1 is 2, minus 2 into sin square theta is 2 sin square theta minus 1. Okay, now simplify it. Okay, let's simplify it. What do we get? Sin theta as it is, 1 minus 2 sin square theta divided by cos theta as it is. Now this 2 and this 1. 2 minus 1. What is 2 minus 1? 1 minus 2 sin square theta as it is. Now if you observe both numerator and denominator, 1 minus 2 sin square theta, 1 minus 2 sin square theta gets cancelled. So we are left with sin theta by cos theta. What is sin theta by cos theta? Sin theta by cos theta is tan theta. So we have got our RHS. Remember again, there was no identity. So we had to take, we had to convert everything into sin theta and cos theta. But already the question is in terms of sin theta and cos theta. So what we did was, we took common, because as we observed, you can take common, isn't it? We took common and we clearly got to know that all we need is sin theta by cos theta. We don't need these two things. So we have to eliminate it. How do we eliminate it? We have to make them same. so that we can eliminate it. The numerator is in terms of sine theta, but the denominator is in terms of cos theta. So what we did was we used the formula cos square theta can also be written as 1 minus sine square theta. On simplification, both numerator and denominator got cancelled. We have got sine theta by cos theta. Okay, students, let's continue the other problems in the next video. Thank you.